Okay, we're going to talk about Lagrange error, day 2 for this. So alternating series remainder, we talked about that previously. So you can kind of read that one on your own. We're just going to go ahead and go through these problems. It should be mostly review. And then just kind of using the Lagrange error in just a slightly different way. So same prompt for the entire thing. So just one prompt, one problem, different parts. Taylor series about x equals 2 for a certain function converges to f of x for all x in the interval of convergence. So the nth derivative of f at x equals 2 is given by this right here. And the original term is 1/3. Okay. So my general term, by the way, will help me find everything. My general term here is, again, this is alternating. So I'm going to get -1 x minus 2 to the n. It should be to the n all over 3 to the n times n factorial. Okay. That's my general term. Maybe I write it like this so it doesn't look as confusing. It's really just this. It should be an n. Really just this times my should be an x minus 2 to the n all over n factorial. So that's my general term. Okay. Probably should have written like this first. This is a little easier to understand because it's taking the derivative times whatever term that we're on right there. So now I can write this out. So second degree, oh, that's not bad. So the initial term is 1/3 plus n equals 1, which is going to be negative 3 to the n. So -1/3. So x minus 2. X minus 2 all over 3 times 1 factorial. Okay, so I'm just plugging in ones into here. Plus x minus 2 squared is positive because it's 2, and this is going to be 9 on the bottom. 9 times 2 factorial. All right, there's my second degree polynomial for that. All right, now show that the second degree polynomial approximates f of 3 with an error less than 0.1. Okay, so let's do our stop and chop here because this is an alternating series here. So this is alternating. This is decreasing in magnitude because the denominator is getting larger and larger. So this decreases in magnitude. And then the limit, if you find the limit of our general term here, the limit approaches 0. Okay, so we can use our alternating series test, which is super nice here. So I'm just going to get 1/3. Again, this is for plugging in a 3 minus 1 over 3 times 1 factorial plus plug in a 3. I'm going to get, again, 1 over 9 times 2 factorial, which is going to be 18. Just keep going here. Minus, it's going to be 1 over, if I'm plugging in a 3 now, 3 to the third, which is 27 times 3 factorial. Which, by the way, this is going to equal, I don't think I have that value. 27 times 6. 162. Okay, so this is going to be equal 1 over 162, so I can stop and chop it right there. Okay. So, well, I have this. So, I want to say so that we can use the alternating series remainder theorem to show that the error is less than this 1 over 162, which is less than 1 over 100. All right, so we just showed that. So that was not new. All right, so next problem here. The f be a function that has derivatives of all orders, so it gives us these values. So find a third degree polynomial, totally fine. So we can do that. So third degree polynomial, since it gives us these values, it's going to be 4 minus 1/3 x minus 2 because we are centered at 2 minus 1/5 times 2 factorial x minus 2 squared plus 3/7 times 3 factorial x minus 2 cubed. All right. And on AP, that's 3 points right there. Use your answer in part A to estimate the value of 2.8. So I'm going to plug in 2.8 here into here. So let's just pretend I do that. Save some time. Okay. Now let's use the information from the graph, which is the fourth derivative right here, to show that this is less than 8. So this is, again, this is r sub 3, or we need r sub 3 of x. Okay. Because we're using this graph right here, so I need, and I'm given the third polynomial. So this is going to tell me that I'm using the fourth derivative of z, x minus 2 to the fourth, all over 4 factorial, which is, by the way, and this, again, is f of 2.8 minus p of 2.8. Just notation. Okay? So if I can find this, then I just need to prove that that's less than 1/8. Okay, let's go ahead and do that. So this is less than, so now what's the largest value? So look at my fourth derivative here. What's the largest value here? Largest value is 7. So at 3, you get 7. So again, that's supposed to be the maximum. So that is 7 times x minus 2 to the fourth all over 4 factorial. All right, so if I were to plug this in, so it gets 7 times 2.8 minus 2 to the fourth all over 4 factorial. This is 0.119. By the way, 1/8 is 0.125. So I just showed that this is true using Lagrange error bound. Okay, so just following the string right here, I'm saying that this right here is less than 0.119, which is less than 1/8. So my error is relatively small. And that is going to wrap it up for this video.